Okay. I'd like to start directly with the title slide, if you care.
All right. So we will click on the slides, and what slide should we go to? There we are.
Perfect. Thank you. So, hi everybody. My name is Fabrizio Borgia, and of course I'm also presenting on behalf of Professor Maria de Marsico. And today I'll be talking to you about our proposal for the recognition of handwritten SignWriting symbols within the Stewart project. Next one, please. Next one. And another one. As most of you already know, the only required tools to use SignWriting are a pencil and a piece of paper. Anyway, since the early years of SignWriting, the need to produce a digital version of the system was evident. The informatization started in 1986 with the SignWriter computer program, allowed SignWriting to achieve a wider diffusion through newspapers, books, websites, and other digital resources. Next one, please. Thanks to such informatization, digital versions of the glyphs were created. The conceptual organization of the whole system was ensured by assigning to each glyph a unique ISWA code. Such ISWA code encodes the linguistic and productional features of each glyph. On the bottom of the screen, you can see a handwritten glyph and its digital version. Next one, please. So, our main concern as computer scientists are SignWriting Digital Editors. By SignWriting Digital Editors, we identify any software that enables the creation of digital resources written in SignWriting. In other words, such editors are critical for the informatization of SignWriting, and therefore for the digital writing of sign languages. Many applications have been produced by different teams, delivered in different ways ranging from desktop to web to mobile applications. Next one, please. We analyzed a number of SignWriting digital editors, and we noticed that they all basically provide the same functionalities. Despite differences in design and implementation, they allow the user basically to search for a particular glyph within the ISWA or to type them directly from the keyboard. They allow the user to insert the chosen glyph onto an area which is designated for the composition of the sign, and they allow the user to manage the glyph on the sign composition area using basic editing operations such as rotation, deletion, and so on. Last but not least, such editors allow the user to save his work, to save the sign he composed, in one or more formats, according to the preferences of the user. Next one, please. So, despite their increasing capabilities, SignWriting digital editors are still far from the simplicity of the handwriting approach. I'd like this concept to be very clear. Next one, please. That's mainly because any SignWriting digital editor developed so far relies heavily on the WIMP interfaces. WIMP stands for Windows Icons Menus Pointer, which is the most common and most popular interface style in the world. I'm sure that the 99% of your electronic devices use an WIMP interface. So, such editors require a navigation and selection process which must be performed over a huge amount of digital images. This process can, of course, be facilitated with a clever and a careful design process, but such process is still long and cumbersome. Moreover, working with a group of deaf researchers at the ISTC CNR here in Rome, we observed that SignWriting users are more fast and comfortable when using handwriting rather than when dealing with the complex interaction style of a SignWriting digital editor. Why is that? That's simply because writing is easier than understanding and using a user interface. Next one, please. Observing such phenomena, we created the SWORD project. SWORD stands for SignWriting Oriented Resources for Deaf. Such project has already been introduced by Claudia Bianchini and Maria De Marsico on presentation 1 and 4. Anyway, SWORD is a project which aims at the full SignWriting-based integration of deaf people in the digital society. Using the SWORD label, we identify a set of digital artifacts, such as applications, websites, and so on, which feature and support deaf-oriented accessibility via written sign language. A SignWriting digital editor, whose name is Swift, which was presented in presentation 4, was already produced within the SWORD project. Next slide, please. Anyway, by performing usability tests and by studying our application, we noticed that Swift still carries the most intrinsic shortcomings of its peers, including the strict dependency on WIMP interfaces. Next one, please. So, here is our idea. We designed a new generation of SignWriting editors able to partially overcome the concept of the WIMP interface and to move along the line of the so-called natural interfaces. Such editors will require neither searching nor browsing or clicking or dragging on the user interface during the SignWriting production process. In the image in the slide, you can see a person interacting with its tablet. That's because our main goal, our dream, is to make writing digital SignWriting as easy as using a pencil on a tablet.
Oh my.
Next one, please. With such editors, the user will be able to handwrite the glyphs rather than seeking them among 1,000 others. Afterwards, each handwritten symbol will be processed and replaced with its standard ISWA version by a recognition engine, which is the main focus of our work. The typical advantages of a digital editor will be preserved, such as multiple save options, the availability of a database which can store any sign composed in order to perform linguistic research and statistic analysis. Next one, please. Anyway, WIMP interface style is currently one of the most common interface style, and of course it cannot be totally left behind, because the interaction with any application, with most applications, is still firmly grounded on it. Nevertheless, our aim is to limit its use or to dismiss it whenever possible during the SignWriting composition process. Actually, our main goal is to completely dismiss it during the glyph writing phase, which takes most of the time of the SignWriting composition process when compared to editing operation or and so on. Next one, please. So, our team at Sapienza University of Rome is focusing on the recognition engine for SignWriting, and of course we are facing multiple challenges. The first one is the very high number of glyphs, in the order of the tens of thousands. The second one is that the SignWriting compositions have a multilinear two-dimensional arrangement. The third one is that using SignWriting, there are no rigid rules for composition. Is it not uncommon to see SignWriting signs written using 3 heads or more than 2 hands for different purposes? So there are no rigid rules which govern the composition process. Last but not least, SignWriting has a complex segmentation. This means that for a machine it's not easy to distinguish one sign from the other. And also, when there is an overlap of glyph, it's not really easy to tell one glyph from an overlapping one. So we have complex segmentation problems. So for the reasons I just mentioned, any OCR-like pattern recognition approach is not feasible. More specifically, there's a very huge amount of patterns to recognize, so it would take an unreasonable time of machine training in order to achieve this by pattern recognition. Next one, please. Before going further, I'd like to introduce the definition of SignWriting Optical Glyph Recognition. From now on, I'll be just saying SignWriting OGR. So, what is SignWriting OGR? It is an application module designed to operate the recognition of user-produced images containing handwritten or printed SignWriting symbols into machine-encoding SignWriting text. Of course, it is more interesting to recognize handwritten symbol, but our OGR engine should be also able to recognize printed symbols. In the right side of this slide, you can see an example of a handwritten SignWriting text that we will find again later. Next one, please. So, our recognition of the SignWriting glyph is performed by taking into account simply the geometric features of the glyph, the topological information and relationships about the glyph, and we have a big help which comes from the knowledge of SignWriting. We can exploit the contextual information about the organization of the ISWA, so its organization in categories, group, base symbols, and so on. Next one, please. Okay, I'd like to show you a very high-level blueprint of our application. So we'll be explaining one slide after the other what happens in our new generation of digital editors. Let's go with the next slide, please. So, it all starts as the user composes a SignWriting text, which is an image. Of course, then the user can compose it using a tablet, or he can just take a paper document with SignWriting characters and scan it. The user supplies the image to our image acquisition interface, which would be very, very simple. Let's go with the next slide, please. The image acquisition interface simply passes the image to our optical glyph recognition engine, and this is where the magic happens. We have an optical glyph recognition module which actually perform the recognitions of any or most glyph within the image, and then the data are passed to a data embedding module. What is it? It's just a small application module which takes all the glyph recognized into an image and creates another image just with the digital glyphs. Next one, please. As the image is created, it is returned back to the user. That's why. That's because no recognition can be 100% accurate. So we need the help of the user to review the whole recognition, the results of the recognition. For example, the user can delete or edit or add any number of glyphs that he wants. So we have a recognition which is performed in two steps. The first one, the big part of it, which is performed by our OGR engine, and the finalization of the recognition, which is performed by a human, which is, in most cases, the most reliable way to perform recognition. As the review process is over, the user can save the image or the XML document in any format he wants, just like a normal SignWriting editor. Next slide, please. So, how is it performed, the recognition? So, the recognition is performed by 4 different analyses of the image. The first one is a kind of preprocessing. This means that we apply noise reduction and thresholding in order to get rid of any noise that can come from a bad scanning equipment or any flows into the input image in general. The second one is an analysis of the image, which aims at detecting the geometric shapes within the image. We all know SignWriting, and we all know that there's a fairly great amount of circles, rectangles, triangles, trapezoids, and so on. So during this analysis, we simply identify the location and the type of the geometric shapes. During the third scan of the image, the machine operates what we call a category inference. What does it mean? It means that for any geometric shape detected into the previous analysis, the system tries to guess the category or the group of the glyph. I'll give you an example. If I detect a very big circle within my text, I can infer with a certain level of certainty, of accuracy, that circle could be a head, or it could be a curved movement. Or if I find a rectangle within my document, it could, according to its dimensions, be a hand, be a symbol for the shoulders, or it could be a punctuation symbols. I have multiple options. So in this stage of the application, the system guesses the category or the group, if we can, of the glyph. During the last scan, which is the final scan, the system performed a number of very accurate checks evaluating the geometric, topologic features of the glyph and our knowledge of the ISWA in order to precisely recognize the glyph. By precisely recognize, we mean that the system must find out the exact ISWA code of the glyph. So, in order to do this, we had to devise a whole new coding for SignWriting. The coding we invented does not replace ISWA because it serves a very different purpose. Such coding is named OGR coding, and I'm sorry, go to the next slide. So, such coding is an alternative coding for SignWriting symbols, and it only takes into account geometric and topological features of the glyph, unlike ISWA, which takes into account linguistic and productional features of the glyph. So, the main advantage of our OGR coding is that the SignWriting OGR module can detect it automatically without the help of any humans. So once we have the OGR coding of the glyph present into the image that the user made, we just have to convert from OGR coding, which is geometrical, to the ISWA coding, which is linguistic. In order to do this, we must have a number of conversion tables, which we can see into the next slide. Next one, please. So, this is a simple text document, but is actually a mapping table. This is the mapping table for the eyes area. We can see from one side our OGR codes, which are very simple because we have a few glyphs for the eyes when compared, for example, to hand configurations. And on the other side, we have the matching ISWA code. In this very example, we use the ISWA Bianchini codes, which is the alternative ISWA that Claudia Bianchini introduced into the first presentation. So, next slide, please. Okay, finally, let's see the OGR in action. So, this is a handwritten text. If you look carefully, the first column is the one we already saw in the previous slides. The first operation on such text is, as we already said, the binarization and the noise reduction of the image, which is the preliminary phase of scanning. So let's go to the next slide. Okay, this is the same image, but if you look carefully, you can see that a number of circles, rectangles, and also triangles, which are blue in this image, have been detected. You can see that most of the circles, I think all the circles, are around the heads, while we have rectangles on hands, on some movements, and so on. So this is the analysis where we detect the geometric features of the glyphs. So let's go to the following slide, please. This is a partial result of the recognition. So you can see that all the heads have been recognized with their variations, and a very large number of the hands configuration have been recognized. Of course, you can notice that something is missing, because we are actually developing we are at the final stage. We are developing the glyphs for the head expressions. So we have eyes, noses, and mouths, which will be available very soon. And we have already completed, but we are still working on the movements of the hands. So very soon the movements will be available. There are also a number of other categories and groups which are easier to detect, but we mainly focus on the hard targets, such as the hand configuration and the movements, which compose a very big part of the ISWA. Next one, please.
Next slide.
Yes.
Is this it? Does it say SW-OGR in action?
No, it's the next one.
Okay, Steve, next one, please. There. Oh, my goodness, that would create a laugh.
So, I'd like to quote Dr. Frederick Frankenstein from the famous movie by Brooks by saying it could work. So
Dr. Frederick Frankenstein. Wow.
So next one, please. So at first, the SignWriting Optical Glyph Recognition was just an idea. We investigated if that was possible, and we started producing an application which is actually functioning. So we can state that SignWriting Optical Glyph Recognition is possible, that our SignWriting OGR engine makes digital handwriting of SignWriting real, and we can also state that overcoming the WIMP interface in digital editors will make the sign composition process fast and comfortable. As for the future, as you have seen from a couple of slides ago, SignWriting OGR needs to be expanded because we need to add support for more and more ISWA categories and groups. Another thing that is important is that our engine has two main purposes. The first one is the real-time recognition of SignWriting glyphs, drawn possibly from a tablet, from any pen-like device. But another very useful application could be a mass corpora digitalization, because from our experience with deaf people, we learned that there is a very big amount of SignWriting paper corpora which could be digitalized and spread to the world. So our SignWriting OGR engine could make this possible with some work. So we are also started designing and developing another slightly different line of research, which is the transcription from videos. Of course, transcription for videos is a very delicate topic because we have to deal with segmentation problems. We have to deal with hardware problems, so we cannot employ very expensive hardware in order to perform our recognition, because we'd like the transcription from videos to be available to as many people as possible. So it is a very delicate topic, but we are starting working on it. I think this concludes my presentation. I thank you all for watching and for your attention.
Okay, well, first of all, you're not going away, Fabrizio, because I want to ask you questions. But
I'm not planning to do so.
And thank you for the presentation. It was excellent, and I was really, really impressed with it. In fact, boy, do I have a lot of questions you wouldn't believe. So I guess maybe the first question I have, because I'm just a layperson, remember, can you see yourself? I have you up there. You see, as a layperson, a person who might use this, but I'm not a computer programmer myself, when you mentioned this great ability to be able to handwrite on a tablet,
yeah,
and then your software, the OGR, will be able to recognize that and put it into a computer. Is that right? That's sort of the general synopsis. Okay.
Yes, exactly.
So right now, where does it stand? I'm sure it's not completely developed. It's probably got a long time to go. But the goal, I would assume, is that someday we could even use an iPad. Is that possible?
Yeah, that's exactly my point. Yes. Is it so?
Yes, so. And can we even test it right now, or is it not in that stage yet?
Well, we mainly focused on the application part, on the inner application part, which is the hardest part, which is the recognition engine. So we don't have right now a user interface to test the engine. The images that you saw into the final part of my presentation are a snapshot which we took at a development stage. So it is still all in
development. Oh, of course, that's totally understandable. You're just sharing with us what you've started. It's wonderful. And congratulations on how far you've gotten already, which is just amazing. I mean, but I can well imagine that we could actually start writing on an iPad. Wow. And then you could get, and then, I know, and then you could get it into, you know, software, and it would be able to be read and become like a published document, right? A little bit like OCR for optical character recognition for voice, right?
Exactly.
Yeah. Yeah, like, for example, I'm sure everybody else out there who's maybe new to this idea, perhaps you've already used a scanner, and the scanner gives people the opportunity to choose OCR, which would mean that your words would be coming into the computer, and the software would try to recognize it, wouldn't it? And yes. In fact, we're looking at a slide right now that Steve put up, and I think it's a good idea for people to understand this, that just to repeat it, because, you know, these topics are totally understandable to you and to other software developers, but for our audience, we have so many different kinds of people out there. We really don't know who's watching, and every one of us comes from a different profession. So I think it's a good idea to realize that essentially this beautiful project may make the day when, just like you can scan and get an English text, let's say, scan it in and it becomes a Word document or it becomes a text document, that just might happen someday because of this work for SignWriting. Isn't that true?
Yes,
So,
yes, I confirm.
that's to confirm it. And so the OGR, the G represents like a glyph, as you have here,
Exactly.
or graphics, you know, another word, yeah. So,
Glyph, G stands for glyphs, yeah, because that's the way we call them. We call SignWriting symbols here in Italy. So we
yes, I know. And that's perfectly fine. What to call the symbols has been kind of comical, I feel, over the years, because I always thought terminology didn't matter very much. But now I'm starting to realize that actually it does, because it's becoming a part of all the names of all the software that gets out there. So yeah, you're right. The word glyph has become equivalent to the old word that I used to call symbols. Yeah. And to this day, you're probably going to hear me say the word symbols because I've gotten so used to that it's hard for me to change over. But that's still the same thing to me. So this is a way for us to do handwriting, and you will make it possible someday to make that into documents. Now, let me ask you, would your handwriting recognition software, would it go into different kinds of software out there that uses SignWriting?
Yeah, that's the main point, because actually we are planning to integrate it into our digital editor, which is Swift, but we are planning to make it available as a web service, maybe for other applications, such as mobile applications or web applications, so that the digitalization of SignWriting can be made by everyone in a very easy way. So yeah, that's our goal. We're planning on making the recognition engine independent from the other application. They can use it whenever they want.
Yeah, I like the idea of the web service. That sounds like a wonderful idea. Huh. Wow, the world keeps growing, doesn't it?
Yeah.
I bet this is really going to spread, Fabrizio, because as far as I can tell, people really still write by hand in SignWriting, don't they?
Yeah, we observed that, and we can confirm that it's very easy to write by hand. So,
you know, it really is comical. I got so much criticism when I first began setting up a website in around 1996, although we already had SignWriter DOS. When it went up on the web and I invited people to be involved with the SignWriting list, that's when we all began the internet adventure together. And I had one linguist after the other tell me that nobody could write this by hand. This is a bunch of nonsense. The only way it could be written would be by computer, because nobody could do that. And I just didn't know what to say. You know, I have hundreds of documents. Just here in my office, I'd had somebody just write a whole bunch of stuff by hand. How do you tell somebody who's skeptical that it's actually being written by hand more than by computer? Even after all the incredible work that's been done since then, it's still true. Yeah.
I think, should I use SignWriting for my everyday use? For example, to leave a message on the fridge to my sister, I could write it by simple. Of course, I wouldn't use the computer. So we're planning to make available the same easiness to the digital world.
Oh, I'm delighted. And now I'm going to go to the next question that has been on my mind about the work about the video transcription. I'm sure that it's clear, but I need it to be repeated to me to explain what your thought is. What are you talking about transcribing by hand and then using the OGR, the handwriting recognition, to then put that video transcription into the computer?
Well, yeah, that's slightly different. We are planning to develop something like SignWriting OGR, but for the videos. So the computer should take care of transcribing as much as possible from an input video, and then, of course, their user can review the transcription from the video and decide, okay, this part is not important, this part is not correct, I want to add my own annotation, and so on. So our aim as computer scientists is to make the machine do most of the job. So,
wow. So what do you mean by that, though? Because you see, in our world so far, I'm just telling you where we are right now here. When we do video transcription, boy, it ain't automatic. Excuse me, that's a joke. It is not automatic. It's simply that we look at the video, and then we either use a computer to type what we see, or to create what we see in probably SignPuddle or possibly SignWriter Studio or other programs, and we're going to soon try Swift, of course. But my point is that we're using either computers or we're writing by hand, but nothing is automatic. There is no automatic writing of a video that I know of, except I do know that there have been software developers who wanted to do that. So I'd like to ask you what you mean by the computer is going to do as much as it can. What do you mean by that?
We mean that the computer will encode, will transcribe much of the hand configuration, movements, head expression involved within the video.
Wow.
Of course.
Wait, I still have to understand it. Are you saying that you're going to develop software that will help this process along?
Yeah. Of course, we already started. Of course, we are quite far from, even from a middle stage of development. But the basis, the foundations of the system have been laid. So we are trying to investigate that possibility. Of course, it is like SignWriting OGR. You cannot completely know if it is possible if you don't go that way. And we are going that way to see if we can apply an automatic transcription from videos.
Okay, well, I just love this. You don't mind? We do have time. We don't have our guest here yet. I hope that Eddie will come. Eddie, you can come anytime. That's our next presentation. But meanwhile, Fabrizio, this excites me because there's so many different researches that have happened before that you probably know all about. But just so you know, there are already people working on doing captions on a video written in SignWriting. So in other words, they're in Brazil. I can send you the information later.
I'd be glad. Yes.
You know what I'm talking about, don't you?
Yes.
And so captioning is different than what you're talking about, right?
I'd like to ask, are such systems automatic or human assisted?
Well, let me explain that I feel a slightly bit embarrassed. I want to make sure that I get the proper name. It was a long name with 5 names, and I don't want to make any mistakes. And I will contact him, and I can put you in touch with him. And yes, there is a young man in Brazil who, as a part of his thesis, I believe, developed a way to do at least, automatic real captioning right on videos. And what I'm not sure I understand yet, because I've never used it, is whether they were videos already signing in Libris and then bringing that signing into the caption, or whether it was some other way of getting written SignWriting captions that maybe somebody would produce and connect to the computer. You see what I mean? That somebody might be producing them and they would automatically plop onto the video as it's being shown. I'm not sure which it is, and that's why you need to talk with him. We call him Ronnie. Hello. We'll contact you, we promise you. But you can see there's so many ideas, right?
Yes.
And it's just amazing. And I know I'm changing the subject, but we still don't have our guest, so I'm hoping Eddie will come soon. So let me tell you another little development that, again, it was done in England as a part of a dissertation by somebody named Gan Liu. And he developed a glove where you were actually doing sign language, and it wrote the SignWriting on the computer screen. So, yes, go ahead.
It is, of course, a nice idea, and I am sure that the glove can very accurately guess the configuration of the hand. Our goal is to do it with cheap equipment. So equipment which can be found in anybody's house, and we are planning also on recognizing the basic features of sign language, which are, of course, the hand configuration, the movements, and so on, but also the facial expressions, which are a key part of the sign communication.
Yes. So you're doing something else entirely. So how would one use it? You would put your video into the software and it would somehow analyze it?
Yeah. Actually, the greatest problem, as I already said, showing you the last slide, is the segmentation among the signs. For example, if one person is producing sign language, so it is signing on a video. For the machine, it is very difficult to tell where a sign starts and where it ends, because in many cases it is just a continuous flow of signs. So that's one of the main issues of the transcription from videos.
Yes, okay. I just invited Eddie, so I get a little distracted. You have to forgive me. It's just the way this is. This is like being in a living room where all kinds of things get us interrupted, so it's just part of life. But this really means a lot to me. I love this project. I think the idea of the video work is really, really complex. You've taken on quite a project here. It'd be a long part of your life, is my guess, Fabrizio. But what brought you to SignWriting? Why did you become interested in doing this rather fantastic kind of programming?
Well, actually, it was almost by chance, because I finished my course of study in computer science, and I was interested in image processing and so on. But then I got involved in this project, and I loved the human part of this project.
Yeah.
I think that human-computer interaction is one of the most person-friendly part of computer science. So I got involved very, very soon, and I'm still involved. So.
Yeah, and now you're here, right? And now we know each other, which is a real blessing. So, yeah, the videos are really fascinating because, just so you know, in the past, transcribing videos started out receptive in our world. I'll explain this in my presentation 40 at the end of the day. And because that happened, because I was hearing and didn't know any better really, but also because at the time, I obviously was looking at videos that a researcher in the University of Copenhagen had given me to transcribe. So I was a dancer and a dance writing expert, and I simply used the system to record body movement in general. And to make the long story short, I started out receptive. Well, over time, as our deaf friends here started really writing, it became expressive because they asked for it. I mean, it was a demand. It was not just a simple thing. They said, look, we feel this language. We want it to be ours. So then what happened was doing video transcription when we went expressive in our writing was really complicated. Now what do? We're looking at this video and it's facing us in a receptive mode, and we're just watching this person, and yet we got to become the signer, and we have to be able to write it expressively. That's basically what happens when we're doing video transcription now. And I've gotten used to it because I have the skill. Not everybody can. It's really hard. And a lot of people start out receptive and then they realize, no, I got to write expressively because that's what everybody else wants. So your computer program also has to take that into account, doesn't it?
Yes, of course it must.
And that's hard. I am going to really look forward to using your work. I want you to know that. I hope you will continue to give us all kinds of information that I can put up on your presentation pages for everybody. So you all know we do need to start the next presentation. So I want to thank Fabrizio and also all of those who are connected with his work. Here's Maria. Hi. I want to thank you so much for all of your beautiful research and your ongoing software development. and your ongoing gifts to the world. Go ahead.
We hope to communicate with you in the future and also to have a connection with you to work together and to have your suggestion, because now we are in a very critical phase and transcribing from video is very hard for all the problems that Fabrizio spoke about. So that I think we will need your support. So be ready for us.
Well, you've got my support 100%, and it's all to our advantage, of course, because it makes the development even more useful to everybody around the world. So
Sure.
Thank you very much for your beautiful 3 presentations at this symposium. Bravo.
Thank you.
That was
Bye.
a very